let's determine if the piecewise function x squared minus 3x minus 10 over x plus 2 whenever x is not equal to negative 2 and negative 7 whenever x is equal to negative 2 is continuous at the point x equals negative 2. So first criterion, check muna natin kung f of negative 2 exists. So since f of negative 2 ang hinahanap natin, gamitin natin yung equals negative 2. So eto siya. So we have negative 7. So check. Second criterion, the limit of f of x as x approaches negative 2 must exist. Ano ba to? So ang gagamitin natin is yung not equal to negative 2. Kasi di ba kapag kinukuha natin yung limit, kinukuha natin yung values approaching negative 2 but not equal to negative 2. So etong gagamitin natin. So we have the limit of x squared minus 3x minus 10 over x plus 2 as x approaches negative 2. Then we can factor this out. We have x minus 5 times x plus 2 over x plus 2 as x approaches negative 2. So since we have a common factor here, pwede natin siyang tanggalin, which leaves us the limit of x minus 5 as x approaches negative 2. Then by direct substitution, that is equal to negative 7. So check, nag-exist ang kanyang limit. And the last criterion, f of negative 2 must be equal to the limit of f of x as x approaches negative 2. So we have negative 7 equal to negative 7. So check. Therefore, ang ating conclusion ay f of x is continuous at x equals negative 2. Let's determine if the function g of x equals sine 3x over 3x squared minus 6x is continuous at x equals 0. So first criterion, g of 0 must be defined. So we have sine of 3 times 0 over 3 times 0 squared minus 6 times 0. So we have 0 over 0. So first criterion pa lang, hindi na siya defined. Therefore, g of x is not continuous at x equals 0. So let's determine if the function h of x cos x whenever x is not equal to 0 and 0 whenever x is equal to 0 is continuous at x equals 0. So first criterion, h of 0 must be defined. So dito gamitin natin yung equal 0. So 0 siya. Check. Criterion number 2, the limit of h of x as x approaches 0 must exist. So anong gagamitin natin? Yung not equal to 0. So we have the limit of x cos x as x approaches 0. By direct substitution, that is equal to zero times cos of 0. That is 0 times 1 or equal to 0. So check. Then third criterion, h of 0 must be equal to the limit of h of x as x approaches 0. So since we have h of 0 equals 0 and the limit is also equal to 0, then na meet yung ating condition. So since yung tatlong ating criterion ay nasatisfy, then we say that h of x is continuous at x equals 0. So let's determine if k of x is continuous at x equals 1. So first criterion, k of 1 must exist or must be defined. So alin ang k equals 1 we have here? So this is equal to 0. So check. Criterion number 2, the limit of k of x as x approaches 1 must exist. So since dito sa function natin, dalawa ang 1, ito yung greater than 1, ito yung less than 1, we have to check the two one-sided limits. So first, check natin limit of k of x as x approaches 1 from the left, and b, the limit of k of x as x approaches 1 from the right. So from the left, gagamitin natin yung limit of x squared as x approaches 1 from the left, which is equal to 1. And from the right naman, we have the limit of 0 as x approaches 1 from the right, which is equal to 0. And since the two one-sided limits are not equal, then the limit of k of x as x approaches 1 does not exist. So fail tayo doon sa criterion number 2. Therefore, k of x is not continuous at x equals 1. How about if x equals 2? Yung k of x ba natin ay continuous? So let's check. First criterion, k of 2 must be defined, and this is equal to 0. Second criterion, the limit of k of x as x approaches 2 must exist. So again, may dalawa tayong values dyan. So yung isa is less than, yung isa is greater than. So we have to check the limit of k of x as x approaches 2 from the left, and the limit of k of x as x approaches 2 from the right. So this one is from the left. So we have limit of 0 as x approaches 2 from the left. So we have 0. And then from the right, we have the limit of x minus 1 as x approaches 2, which is equal to 1. So since the two one-sided limits are not equal, then we say that limit of k of x as x approaches 2 does not exist. So check dito, ito, hindi siya na-satisfy. Therefore, k of x is also not continuous at x equals 2. Let's determine if j of x is continuous at x equals 3. First criterion, j of 3 must be defined, and that is equal to 3 squared, or that is equal to 9. Next is, so check tayo dyan. Second criterion, the limit of j of x as x approaches 3 must exist. Okay? So in this case, since ang not equal to 3 natin ay absolute value, so we have to check the two. The limit of j of x as x approaches 3 from the left, and the limit of j of x as x approaches 3 from the right. So from the left, we have the limit of negative of x minus 3 over x minus 3 as x approaches 3 from the left, which is equal to negative 1. Then the other one, we have the limit of x minus 3 over x minus 3 as x approaches 3 from the right, which is equal to 1. So since they are not equal, then we say that the limit of j of x as x approaches 3 does not exist. Therefore, j of x is not continuous at x equals 3. And finally, let's determine if m of x is continuous at x equals 4. First criterion, m of 4 must be defined. So this is equal to 4. Ito lang siya. So check na tayo dyan. Next is the limit of m of x as x approaches 4 must be defined. So dito naman tayo titingin. Observe that dito sa function na to, pag plinag-in natin yung 4, okay, magiging 0 siya. Okay? So, ang gagawin natin, we have to multiply the conjugate. So, we have 4 minus x over 2 minus the square root of x as x approaches 4. Mag-multiply tayo ngayon ng 2 plus square root of x, which gives us the limit of 4 minus x times 2 plus square root of x over 4 minus x as x approaches 4. So, pwede na natin itong tanggalin. Then, we now have the limit of 2 plus square root of x as x approaches 4. By direct substitution, that is equal to 2 plus square root of 4, so we have 4. Therefore, the limit of m of x as x approaches 4 is equal to 4. So, check na tayo dyan. And finally, the 2 must be equal. So, since m of 4 is equal to the limit of m of x as x approaches 4, that is 4 equals 4, therefore, satisfied yung ating third criterion. So, since satisfied yung tatlo, then we say that m of x is continuous at x equals 4.